This video, we're going to prove an interesting fact. D are all the divisors of n. And if you add up the reciprocal of all those divisors, then you're going to get sigma of n over n. Okay. Proof. First, if you like seeing mathematical proofs, then I advise you to subscribe to my channel, as this is all we do here. We do mathematical proofs. So let, in increasing order, let this be a list of all the divisors of n. Let D1 be less than D2, which is less than D3, which ultimately is less than D sub r. Now, just for the record, the largest number that goes into a number n is the number itself. That is, it turns out that D sub r is the number n itself. Okay. So now, the summation of all the divisors of n, we're going to add up the reciprocal of all the divisors of n. So we're going to get 1 over d sub 1 plus 1 over d sub 2, all the way up to 1 over d sub r, which is actually 1 over n. Now, I look to see what I want. I want an n in the bottom. Okay, so how about we multiply by 1 as n over n. So I have my n in the bottom, looking closer to what I want, and then I distribute. I get n over d sub 1 plus n over d sub 2, all the way up to n over d sub r. That is n over n. Now, I claim that each of these divides n. I claim that d sub I, n over d sub I, goes into n. Okay, so let's write that up formally. Okay. I claim n over d sub I divides n for I equal 1, 2, up to r. Well, if you look at n over d sub I, does it go into n? Sure it does. Instead of dividing the top n by that, I could multiply by the reciprocal, and yep, it goes in d sub 1 times, which is an integer. Okay, so yes, each of these are divisors of n. Now, that's interesting because we only have r divisors of n. And here I have a list of r divisors of n. Doesn't mean that those are all of them. There might be duplicates. Okay, make another claim. I claim that n over d sub I does not equal to n over d sub j for I not equal to j. Well, if n over d sub I is n over d sub j, if two fractions are equal and the numerators are the same and the bottom is not 0, if two fractions, legitimate fractions, that is, we're not dividing by 0, and 0 doesn't go into n, so, or 0 is not a divisor of n, so what happens is, if the numerators are equal, the denominators have to be the same. Okay? which implies that n over di for I equal 1 to r are distinct divisors of n. Okay, they are distinct divisors of n. So as of right now, we have the summation of the reciprocal of d, where d is the divisor of n, and this is equal to n over d1 plus n over d2 all the way up to n over d sub r, which is n over n. But those are the divisors. These are the divisors. One of these will equal d1, one of them will equal d2, one of them will equal d3, etc. Those are the divisors of n. Wait a minute. We're adding them up. Ah, that's sigma of n. Oh, okay. We're dividing by n. There's the proof. Done. Okay, there's the proof. Okay, just think it through, and you guys could possibly do most of these on your own. If not, subscribe to my channel. Keep watching my videos. Watch and learn. See you guys in the next video. Have a good day.